Well, then you now find the answer to your question. You can now go solve the problem that you're trying to solve. If we're able to comb through thousands of documents and extract all the relevant information that you're trying to extract, you now have that information and you can go do your problem. So it's really trying to just remove everyone away from doing the mundane, low value work that can drive you crazy to really just focusing on doing your most meaningful work.
Welcome to UpTech Report. This is our Applied Tech series. UpTech Report is sponsored by Terraleap. Learn how to leverage the power of video at terraleap.io. Today, I'm joined by my guest, Ryan Welsh, who's based in San Mateo, California. He's the founder and CEO at Kyndi. Welcome, Ryan. Good to have you on.
Thank you very much. Thanks for having me.
Now, Kyndi is a natural language technology platform focused on serving enterprise. This includes industries of manufacturing, life sciences, insurance companies, government. And you're really working with those CIOs, CTOs, head of research, helping them implement natural language technology into their enterprise to help them understand what the heck is going on and be able to search and get information faster. And we'll dig into what all that means in a second. I'd love to kind of hear from you, Ryan, though. Help us understand, help us understand the playing field here. What's the challenge that you see in these industries that you're helping serve? What are they facing right now?
There's actually two layers to the problem. The first is from a user perspective. So 77% of enterprises today still process text data manually. Like that's a crazy thing to think about in our modern digital world.
When you say process text data manually, like you just help me, give me an analogy here.
Sure. The process text data, look through all these documents and pull out all the interest rates, right? If it's a financial document, like literally 2.5%, X% plus LIBOR, something like that, like pull out all these interests, like, okay, so now they're doing all that manually. Look through all this text data and find answers to questions, stuff like that. I mean, they're spending so much time and effort looking through all this text data. And it's because machines can't understand natural language. And so there's the end user problem that is employees spending anywhere from 1 to 2 days a week looking for answers in and extracting information from text data. But then there's a problem below that where actually getting machine learning to work in the enterprise is incredibly hard. And it's hard because you need to hire a bunch of AI talent, and there's not many people in the world that know how to use these algorithms for specific problems. And it's also difficult because it requires a lot of label training data, which enterprises don't have. And so there's the end user problem, and then there's actually the data science, the IT, the platform problem. And so, as a platform company, we like to solve the platform company or the platform problem so that people can then use these technologies and embed them in applications to solve end user problems.
You highlight the underlying issue of, okay, we are spending a lot of money, energy, people, resource, time on entering all this data manually. Technology exists to solve it, and it's not terribly new. It's been around for a couple of years, but actually implementing it has been the challenge, and that's where you guys are trying to address it. Let's hear a bit more about your story, though, of like 7 years ago, right? That you started Kyndi?
Yeah, that's right. That's right. 7 years ago, I started. I had an experience prior to starting the company where we had to read through a lot of financial contracts. So I was working for a law firm back in New York, and it was a securities law firm. And during the financial crisis, when all this stuff went into bankruptcy, we had to reread all the contracts to understand what the heck was actually in them and ultimately try to unwind these things. So, I mean, quite literally, I would spend years. Like there was a 3-year period where I was combing through documents, reading. I mean, it's
so you personally hated doing that, I imagine.
Hated it. It was, I had a graduate degree in quantitative finance and mathematical economics, and here I am spending years just reading through financial contracts. And when you think about it, you wonder, why don't we have technologies that can read and understand natural language? And then when you think about it also is as humans, we haven't been able to increase our reading speed. We're essentially reading at the same rate that our parents and grandparents are reading at. And so effectively, we're the bottleneck in the modern production process, right? We can store a lot of data, we can move it around super quick, but as soon as it hits our eyes, we're still reading at the speed that people read at in the early 1900s. And so
this is back, you're experiencing yourself back in like 2008, 2009, 2010, and you're like, there's got to be a better way. But there's still a few years between that and starting Kyndi. So what did that?
Yeah, so then there's business school from 11 to 13, which is always good. So I went back to the University of Notre Dame, did my MBA. And I got out and I started working for a consulting firm in Washington, D.C. that was run by senior intelligence agency officials. And there I was helping commercializing technology coming out of national laboratories. So very advanced technology, low orbit satellite, quantum cryptography, cyber capabilities, just all types of unique stuff that we develop in our national labs. And then in 2014, I had this thesis that I believed that by 2025, all knowledge workers would need some form of AI powered workflow, and specifically around natural language technology and helping us sift through this information so that we can get through it faster and ultimately spend all of our time doing our most meaningful work. So I started Kyndi in 2014.
So you create a thesis out of your business school, and then you're like, let's turn this into a business.
Yeah, exactly. I actually met a gentleman who was an angel investor in the DC area. And I kind of had this idea of this major thesis. And what's funny was he said, Ryan, that's interesting because I had met a scientist that's looking for someone that knows math really well and knows business. And so this gentleman actually set me up with my technical co-founder on a founder's date. And we met and we hit it off and started Kyndi, a week or two later.
That's a brilliant strategy or tactic of finding your founder, just sharing a thesis with others, and then they can say, I know someone else that has a similar interest, and that creates that bond for a co-founder. Wow.
Exactly. And I was very lucky to meet, his name's Aaron Majumdar. I was very lucky to meet him because he had been in the AI space for years. I mean, for 30 years, he had been mentored by some of the pioneers in the field, including Marvin Minsky, John McCarthy down at Stanford. He was a part of McCarthy's formal reasoning group down at Stanford, mentored by people like John Soa. And so the reason why I bring that up is I was able to get a crash course in AI from people that really knew the space. And it wasn't like, hey, these machine learning techniques are now starting to be productive. Let's apply them to everything. It was people who knew the entire history of artificial intelligence, really bringing the best capabilities to bear.
So you're bringing the use case, they're bringing the technology and the insight together to then address this problem. When you had shared this with your co-founder of this idea of applying it in this particular way, was there like, yes, this is a great idea, or did it take a little bit of time to come to a fruition on a?
Yeah, what was interesting, and I think I've been pretty good at this in my career, is having big macro theses. And so when you come through and there's these, artificial intelligence researchers that are really in the weeds on doing research, and you come through and you say, hey, I think now is the time to transform the world. They kind of like look up and go, oh yeah, that's why we're doing this, and because they're so in the weeds. And so when you kind of paint the picture of, hey, now's the time to leave the lab, transition it to applying it to specific problems, they get really excited by that. And of course, I get excited by the technology as well.
What year did this happen? Was this in 2014?
Yeah, early 2014.
Okay, and then from there, you guys hit it off. And what happened next? Did it just off to the races?
No. So it's a lot of research. And so what's interesting about the natural language technology space is, when you see AI start to take off in 2012, 2013 after ImageNet, it's all around computer vision. And one of the big knocks on deep learning was that it wasn't good at understanding language. And language is a really difficult thing to understand. And it wasn't until 2018, where with the release of BERT, that you start to see deep learning actually starting to be applied to real meaningful language problems. And so I bring this up because for a good period of time, it was research. It was, how do we apply these specific technologies to understand natural language, and then also matching them to business problems. Because a lot of times I think what people really don't understand with AI is, it was developed in academic institutions, a lot of them, and it wasn't thought about, or at the time, you're not thinking about how does this then transition to a business case, and is it applicable to a business case? So, take for example, deep learning. One of the biggest problems with deep learning is that it requires an insane amount of data to train on, labeled training data. Well, guess who doesn't have that? Businesses, right? Especially when you require web scale data to train on. And so, and so people didn't think about, all right, well, we need to build systems that learn on less data. And they also didn't think about, all right, well, we need to build systems that are explainable. And so when we started navigating the problems of the technology, we actually had to develop new techniques to make it work within the space that we were going after, which was within the enterprise.
You mentioned a little bit ago BERT, which, if I Google quickly, that Google created that. Is that correct?
Yeah.
Was it 20? What year did they?
Yeah, it should have been late 2017. The paper came out and really kind of hit the press probably early 2018.
And it's an overall, I guess, algorithm or a way that one could then understand natural language.
Yeah. It was a really great breakthrough where they started to understand the context of language more. So they looked at both the right and left side of words to really understand what does this word mean. So as an example, a classic example is bank. Is it a river bank or is it a financial bank? Right? It's hard to understand unless you look to the left and right of the words to understand the context of those words. And there was also some parallelization that it enabled, which allowed it to train on much larger data sets and get that context and really start to understand language more.
Bidirectional encoder representations from transformers, for those that are curious.
Exactly.
But basically, you paint this beautiful picture. The academic side, they create these algorithms, and it's beautiful, it's nice. But all right, now how does it cross the chasm, make it to where the rubber hits the road and people can actually use it in a business use case? Is this where then you're looking around, you're seeing these algorithms, you're seeing these existing solutions, and then building on top of it your additional?
Yeah. I would say that's what's interesting about Kyndi is given the brain power that we had early on with the researchers, we started pioneering new approaches. We're starting to solve long-standing problems in the AI space, and so one of the interesting things about AI, and I'll make it super easy, and AI experts, don't criticize me a lot. I'm making it super easy. Is there's kind of two main fields. There's the connectionist approach, the machine learning, the deep learning approaches, and then there's these symbolic approaches. And it turns out that the merits of each overcome the demerits of each field. And so if you can actually fuse the two paradigms together, you have a really rich and robust system. And what's interesting about AI research is that what I found, and this is an outsider's view, is that the researchers in each camp don't necessarily like each other. And so you either work in one or you work in the other, and you believe one is the path to artificial general intelligence, and you knock the other. And so when we came through and said, hey, we really don't care. We want to create a better system. We really thought about how do we fuse these two paradigms together, and how do we really push the state of the art. And that's really what we achieved here at Kyndi. And recently we're recognized as a pioneer by the World Economic Forum for pioneering this field of AI that's now being called neurosymbolic.
Neurosymbolic, which just combines the two pieces together. Help me understand the timeline though. So, 2014, you guys get together, you start the research. How many years did it take then to start to make those connections and build this together?
4 years to prove everything out. So you have some initial, ideas about how things work together. You start to prototype them, spaghetti code. So not production. You're just hoping it works. Your ideas works. You start to then prove it out on business problems. We were working with the U.S. government very closely on some problems that they had in understanding, text data. And you start to just prove out that your ideas, could work, and then start to work in the wild. And that happened for 4 years. And then after 4 years, this is early 2018, we bring in a great CTO that can actually transition science to an enterprise grade platform that enterprises can use. And so we're now around 2018 where we really start to build a product out of the underlying algorithms.
So you really did spend 4 heavy years on the research side, still bringing it to a final product versus just taking something existing and then turning it into a product. You're actually truly building this new product. But then you need to still make that transition to, all right, how do I sign up? How do I actually just apply it to my existing business? Did you immediately know the industries that you were going to be focusing on serving?
Yes. So we did do a lot of customer discovery research around which industries to go after. So you have these kind of natural hypotheses of this industry has a bunch of text data, this industry doesn't. So let's go over here. And what we found was one, we narrowed in on industries that had a lot of text data, but we also narrowed in on industries that had already started to see success with data science platforms. And so there's been a lot of success in applying machine learning, what I'll call advanced statistics, to structured quantitative data. How many red shoes am I going to sell in Kentucky next quarter, right? Like you can collect a bunch of data on that and you can predict and you can be, good at predicting in a statistical way and optimizing certain supply chains and inventory and all of that just around that. And so there was these industries that were seeing success in the lower hanging fruit that we started to say, they're now climbing up the tree to get more and more value out of the harder problems. And we found that the industries that had already realized success with machine learning on their quantitative data were now starting to apply technologies to their harder problems like computer vision and natural language.
I'm curious for you during that 4 years, and then as you got through that, how did you feel? You're not actually in the weeds coding anything or creating it. So were you feeling, oh yeah, this is coming along swimmingly? I'm just curious as an individual, as the leader there, what was that like for you?
Well, there's specific outcomes that you're driving towards, and so we still generated revenue during that period. So we're still selling to customers. So it's not just like pure like research at an academic institution. Okay. Like it was a business. We went out and we sold products to customers that were willing to take on very early research to prove it out. Because if it worked, the upside was massive. And so the bet for them was asymmetric, right? Like, all right, I'll give you $150,000 for, this software for a year and it's full of, just academic code, but I'll realize $30 million in value. like the bet's asymmetric. Yeah,
it is, if anything, they're your beta clients, or however you want to call it, just being able to test it, they get the huge upside. It's an interesting recipe for others also, entrepreneurs that are looking to develop new technology companies, of like finding those who are willing to be your pioneers or early stage or early interest. Was it difficult to find them, or those who are interested in playing with it, or do you see a ready desire for implementing this type of technology? Yeah,
well, there are certain industries that are willing to make those bets, and there's the U.S. government is a great one. So people say, hey, it's really hard working with the U.S. government. There is a lot of red tape, there is, but they're willing to take these bets, and they're willing to fund things to prove it out. Because I mean, if you look back at the history of research and innovation in the United States, it actually comes out of DoD, DARPA, stuff like that. It's only been in the last 20 to 30 years that private institutions have really started to fund all that research, and the government no longer does that research. So they still have a long history of funding very innovative things, and they're willing to take those bets. And there's also companies in the private or in the commercial sector that are also willing to take those bets. But you need to find them, and they are hard to find. You got to go out and embarrass yourself a little bit, and pitch a lot of people, and you'll find someone and they'll pay for it.
Yeah, I'm curious, like how your process. Do you already have those connections? Was it just natural for you, or were you having to reach out beyond your network or specific people that helped you make those connections?
Yeah, you reach out beyond your network. You need to cast a very, very wide net to find the few crazy people that are willing to take this on. But there's when you state an idea of a future state, there's people that like latch on to that. And so, when you say, one of the things that I kept saying was, hey, we're the bottleneck in the modern production process. Like, we can't read and understand information any faster than our parents or grandparents. And I believe that there's technologies that will just significantly increase our capacity to understand that information. Some people were just like, whoa, I get it. And then they're like, I get it. Like, I don't actually get it, but I kind of get it. And they're willing to take that bet because they see the transformation. They see how, you could go from employees spending 1 or 2 days a week to employees spending, 5 minutes, and that's just huge across a 200 or 300,000 person manufacturing company. And so the gains can be massive. You just got to really find your believers and the people that are willing to believe in the future that you're trying to create, and then work your butt off to help make them look great and realize that future.
It makes me think of the adoption curve, where it sounds like you're finding those early adopters, those really innovators, those who love and see the value in the future. That's helpful when you're launching and being able to show the potential of it. I'm curious, are we getting to the early majority yet? Are we able to cross this chasm, or is it a long way off still?
I honestly think it's still a long way off. I'm forgetting the exact categories, but I think there's one even before early adopters. Like what's I forget the very small one before you get to, so early adopters is before the chasm, but there's one even before. So
you have innovators, early adopters, and then early majority.
Candidly, I think we're still at innovators.
Okay, not even early adopters yet.
I don't even think we're at early adopters yet. Yeah, I mean, maybe just in the last quarter or two, like we're starting to get into early adopters. But I honestly think we're pretty far off from.
What's the roadblock? Like what's stopping the early adopters to say yes, let's jump on this?
Yeah, so take search as an example. With AI, you can create a search capability where users can ask natural language questions. So type in questions as if they were asking a human, and the system can return an answer, or in some systems return a snippet of text that contains the answer. Most people will say, hey, I have Elasticsearch. And you go like, there's a huge difference between returning links to documents and returning the answer. and so with I think what a lot of people don't think about is what is the amount of time that my people are spending, when they search for documents, having to read through the documents that are brought back, and what could be improved in that process. And so I think what's kind of super challenging sometimes is when people don't understand they have a problem until you alert them to the problem. And then once you alert them to the problem, they go like, oh my gosh, like this is massive. Like this is absolutely massive and I need to address this immediately. But they weren't waking up every morning saying, this is a very specific problem that I need to solve.
So the major hurdle for getting to that early adopters is agitating the problem, making them realize that there is an issue and a challenge with how they're doing business currently.
Yeah, it is evangelizing the entire space. You know, like you're out going, hey, here's the problems that you have that you don't even know about. Here's the solutions that can address them, and here's the ROI on those, which I think takes focus. And so, you know, I think what a lot of AI companies either aren't willing or aren't capable of doing is focusing on a very specific business problem and solving or delivering ROI to customers. And so they want to kind of stay in this abstract world of, you know, oh, we help you find answers in your unstructured text. Hey, that's great, but what does that actually mean? Right? For who are you finding answers in the text, and why is that better than their current solution? And so, I mean, even at Kyndi, we've had to, you know, err on the side of being incredibly narrow in our focus and say, hey, we're going to help, you know, customer support people. We're going to help, you know, internal IT support. We're going to help these analysts over in supply chain. We're going to help these analysts over in logistics. We're going to help these analysts working in financial services that are trying to read these specific documents and, you know, understand them faster.
And you're applying that specification or addressing that specific individual and use case for messaging purposes or for product purposes, or both?
Both. Yeah, both. Because what I think what you want to do is you want to deliver value to some specific group within the organization so that they can go to their boss. You know, say you're working with a director or a senior director that, given the price point, they need sign off from a VP. Like, they're going to need to say, hey, we're going to pay this company $250,000 a year, and they're going to deliver us $2.5 million worth of value. Here's exactly how they do that. Right. And as opposed to, we're going to buy this for $250,000 a year because there's AI in it. You know, that doesn't work, you know. Would
you say that there has been an AI terminology overload in the past few years of everyone is saying AI this, AI power that?
It is the noisiest space in the world. It is by far the noisiest space in the world. And I can't wait to the day, and I think it's coming soon, where we can actually stop saying we're an AI company. Right. Where you can just say like, hey, we do this specific thing. So, and there's going to be a handful of companies that kind of keep the AI thing going because they're very deep tech AI companies, you know, platform companies. But then there's a lot of companies that I hope that are just, you know, SaaS applications using a little bit of statistics that'll just say, hey, no, we're a CRM solution, right? Because AI isn't, or machine learning isn't a differentiator. Everyone has it. You know, what is the business thing that you're actually doing? And I can't wait to the day that we can actually drop machine learning or AI and we can all just say, hey, we all use it. So let's stop saying. It's kind of like saying like, you know, oh, I'm a software company. It's like, yeah, we get it. Like everyone that is a software company is a software company. Like, we get it.
What value are you doing? What problem are you actually solving? You addressed nicely the getting over that first hurdle of just helping people understand doing a search and coming back with links to your documents is not the same as how Google actually, we're starting to experience that as a consumer more often. I do a Google search, and at the very top, often if I've asked a very specific question, I get a snippet of my answer. Or if I do a Google Assistant and it gets my answer, or Alexa or whatever. But putting that into a business environment, enterprise space. So just helping people understand, educating them. Is there still, though, a roadblock or a fear that arises of will this actually work? Will this roll out well? Because this is still very new. And how do you overcome that fear?
Yeah. We thought about this very early on. And we believe that the people that can deliver value the fastest and demonstrate that it works the fastest are going to dominate the space. And so what I mean by that is in traditional software development, when you write code, it does the thing that you told it to do because you told it to do it, right? In AI, there's this AI engine that candidly may or may not work, like for the problem. Like it may or may not. Like, hey, it works in 90% of the cases, and it may not work in 10% of the cases for whatever reason. And so you're consistently trying to answer the question, does the AI work for your customers? And we think that the people that can actually prove that works the fastest are going to ultimately put systems into production and gain market share. And so yeah, go ahead.
When you say proves it the fastest, you're really saying of someone says, all right, show me. And you say, okay, click this button. Now it shows you. Like the speed of execution from they are interested to it being deployed. Is that the speed that you're referring to?
So specifically working on their data. So here's the interesting thing about machine learning is you can train it on a data set. And if the customer data is not even like totally different, like actually just a little bit different, it won't work on the customer data. And so now you're saying to your customer, okay, customer, collect a bunch of data, send it out to either we'll label it or we'll send it out to some other party to get it labeled. We'll train our algorithms, and then we'll come back in 6 months and we'll show you that it works, right? And so like 6 months just to see that it works on your data is just way too slow. Whereas in traditional software, you could just go in and you can see that it works. Like, oh, this works on my data, on my structured data. Now it's harder what you're doing with machine learning, but just all of that time and energy and effort that goes into proving that the AI works, I think people just lose interest and they say, all right, am I going to have to do this every single time? So say my data isn't static, say it updates. All right, well, how many times do I need to, retune the models and label more data? And now we're going through this process again. And it's like, is it always going to do this? And so, yeah, I think it's both from like first meeting to deployment, but then there's this crucial period in the middle that's first meeting just to proving that it works on the customer data that I think a lot of people fall down on.
I feel like if that happened in the consumer world, consumers wouldn't use a product we assume I'll sign up here, I'll press a button, and now I'm using it. It works.
Yep.
And in the business world, it has to be somewhat as close to the similar as possible.
Yeah. You try to get it there. And so I think the people and so if we look at, so for some of the more advanced AI platforms and use cases like imagery and video and natural language, I think there's a playbook that you can look at in the data science space. So if you look at companies like Data Robot, Data IQ, Domino Data Lab, Databricks has a data science platform. So if you look at the companies that are the leaders in that space, they developed AutoML. And so when you upload your structured quantitative data and you click on the variable that you want to predict and you click on the variables that ultimately you want to use for the prediction, they'll easily generate a model for you to use that is the best model to use. And you can see that value in a very short period of time. And so I think there's a playbook for everyone else for the computer vision, image, NLP platforms that if they can actually pull off what those data science companies have done in delivering value the fastest, will ultimately dominate the space. But the problem is it's much harder than doing it on structured quantitative data.
Coming back to the initial challenge that you recognize when you were having to go through all those pieces of paper and finding those items in the document, like there's got to be a better way. you're painting a picture for a world where knowledge workers don't need to do that the computer just is able to go through all those documents, understand what's the difference is. What's the future then for knowledge workers? What's it going to look like?
Spending all of your time on your most meaningful work. I mean, there's nothing more frustrating than preparing data for the analysis that you need to do. Like, what I really want to do is just solve this problem, but I'm going to spend the next 3 years collecting the data to solve the problem. Like, that's just ridiculous. Or the next several weeks or the next several days. And so it's kind of like everyone has a research assistant, you know, when you think about it. And I think what's interesting about what we do compared to a lot of other AI companies is a lot of like very machine learning heavy companies are constantly trying to automate a process. So they're trying to just remove people out of the process. So let's get this model to 99.9% accuracy and let's get rid of all the people. For us, we're saying, hey, let's have people and machines working together and make them more productive. And so we believe that if we can, you know, help you find the answer to your question in a minute or two versus a day, well, then you now find the answer to your question. You can now go solve the problem that you're trying to solve. If we're able to comb through thousands of documents and extract all the relevant information that you're trying to extract, you now have that information and you can go do your problem. So it's really trying to just remove everyone away from doing the mundane, low value work that can drive you crazy to really just focusing on doing your most meaningful work.
What's the new entry job going to be then? I mean, is it going to stay the same? Because that would be the entry job, right? Hey, you go find all this information, go work on this stuff. But what's the new entry job?
Yeah, I think the entry job just is not so much data processing, but it's you can now apply your skill sets, your creativity and problem solving to actual problems. So I still think there's going to be work that needs to be done. You just won't be doing
AI handler. You're working with AI, you're just handling with the AI. Okay, this is what I got to work with now.
Totally, because things are constantly changing in the knowledge worker space, and so kind of unlike traditional manufacturing, where it's like, hey, this thing does this specific task every day, every minute of every day, every year from now into perpetuity. Like, you know, in knowledge work, it's like, oh, we have this customer that came in with this problem. We have, you know, this person that came in with this problem, and you're constantly like maneuvering. And so you need systems that can adapt with you and work with you to do your most meaningful work. And I still think there's those entry level positions, but they're not data entry, right? They're kind of maybe a little higher up the chain.
Okay, just for fun, everyone ever thinks about AI often will think about Iron Man's Jarvis, right? Like, let me just talk to somebody that can go do the scans, can do a bunch of research, come back to me with my answers. You know, how close can we get to that? No,
I mean, not very. I think a lot of people will say, oh yeah, no, I have a system now that does that. It's like, get out of here, right? It's look, you know, we want to enable people to more easily find the answers in large volumes of text, but it's still up to the person to know what's the answer, right? And these are for very hard questions. So there's simple questions like, you know, how tall is the Eiffel Tower, and you get an exact answer back, or what's the population of San Francisco, and you get an exact answer back. And you can kind of structure that stuff in a knowledge graph, and you can ask those very specific questions and get those specific answers back. But then there's kind of these more complex, not even more complex questions, just different questions that you're looking for the snippet of text. I mean, it could be anything from like, you know, how do I log into my computer? You know, it's not working. Like something simple that's in a knowledge base. And a lot of times you'll get like links to a document that's a user manual that then you then need to read through. Like, wouldn't it be great if the system read through the manual and brought back the exact sentences? This is how you log into your computer. But you know, there's not a lot of systems that can do that, and so we're pretty far away from the Iron Man Jarvis system, and it's more about systems that just bring back more precise information for people.
I feel like if anything, we're training ourselves to maybe ask better questions to start with? Is that another piece? Is like, well, I feel like in the old days of Google, you had to know how to write the question properly. Or is just, are we getting to the point where AI, even if we ask it poorly, it can still understand?
Yeah. So what's interesting about your question is I was talking to someone the other day, and they asked, how are you going to transition people to asking natural language questions? Because people are more familiar with or more naturally inclined to write questions how they write them today. And I thought about that, and I was like, wow, that is crazy. That the first time that I logged on to Yahoo, which was obviously before Google, I wrote a question in the search box that was like I was asking a person. Like, where's the best restaurant in Philadelphia? Because I'm from Philadelphia, and you'd write that question, but it wasn't until you learned that, hey, these systems don't understand what I'm asking. You're putting too much stuff in that question that you now write best restaurant Philadelphia. Like, and what's interesting is this individual thought that we are naturally inclined as people to ask questions that way. When it turns out that we were
reprogrammed.
We were reprogrammed by keyword search to ask questions that way. Now he still has a valid point that there needs to be a transition, because we're now talking about 30 years of asking questions that way. And so we need to get back to asking questions in a natural language way. But I just thought that was really interesting, just kind of how this individual thought that we were naturally inclined to ask these questions. And what's interesting about AI systems today is they can start to understand that context more in your question. And so language has three things. It has syntax, semantics, and pragmatics. And machine learning is really good at understanding like the structure of sentences. It's not necessarily good at understanding the semantics, the meaning of language. And it's absolutely terrible at understanding the pragmatics of language, the intended meaning. And so, if you can start to build systems that kind of understand all three of those things, people can ask questions in a certain way and get answers back that are basically what your question intended to bring back.
Mm-hmm. All right, I'll kind of land on just your predictions of the future. In 5-10 years from now, what do you predict will it look like? What are we going to see when it comes to natural language processing and AI?
Yeah, so I'm incredibly excited about all the breakthroughs that we're seeing in natural language processing, and all the investment that we're seeing in natural language processing. And all the use cases that are starting to be deployed and the focus. So we see like both a supply side of like, hey, algorithms are working and we have these algorithms that can work, but we're actually seeing the demand side as well, where we're constantly getting inbound interest from large Fortune 500 enterprises that want to transform their company into a natural language enabled company. And so when we actually think about, I think there's some statistic like it's 27% of employment costs globally is for knowledge workers, even though they only represent about 9% of the global workforce. And so when you do the math and you say, hey, if we can increase their productivity by 10%, then we're adding $15 trillion in global equity market capitalization, which is just crazy to think about. And I think we're at this point in time where it's kind of, people reference this a lot, but very similar to an industrial revolution, but kind of a knowledge revolution, where we can start to overcome our constraints, like I was mentioning earlier, of only reading at a certain speed, only comprehending a certain amount of information as you read at a certain speed. And so I see this future that is just incredibly efficient and incredibly valuable for all of us, that brings a lot of societal benefits with it.
Those that want to learn more about Kyndi, it's kyndi.com. Help me just understand that. Kyndi, where'd that name come from?
Yeah, it was really interesting. So my technical co-founder and I we were thinking about a name. We're like about to file the paperwork to incorporate. And I said, Aaron, we got to come up with a name. He goes, I got it. It's perfect. I got a perfect name. He goes, we'll call it Artificial Intelligence Thinker Incorporated. And I was like, Aaron, I love you, but like, that's absolutely terrible name. And so I asked him, because he had spent his early years, I think it was between like 5 and 10 or somewhere in West Africa. And I said, did you have a name, a friend's name, or anything that sounded interesting. And he said, "Hey, I had a friend named, I think it was Kyndi or Kyndi or something along those lines." And so I kind of liked that, and we played with it a little bit. And we found, just Googled a name, and we saw Kyndi, Kyndi, come back. And when you looked at it, it said someone with the capacity for thinking and reasoning. And we were like, well, there it is. There it is. It took us all of 20 minutes to name the company. I
love that simplicity of it coming together for that. Thank you so much, Ryan, for sharing the journey that you've been on and the fascinating overall journey we are all on of natural language processing and where we're headed. Thank you.
Thank you.
And we'll see you all on the next episode of UpTech Report. Have you seen a company using AI, machine learning, or other technology to transform the way we live, work, and do business? Go to uptechreport.com and let us know.